another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I would like to officially welcome all of you to the 4th year of the Dark Assassins podcast, and our first full year on YouTube is also now in the books. We go into year 2 on there. Now, just to kind of give a quick recap of how things have gone there for full transparency's sake, granted, we did have a few videos on YouTube, and by a few, I mean 3, that were not for the podcast. I did release a couple of just generic tutorials, but we amassed 138 subs over there and 4.6 thousand views. So thank you all for being able to share this around and just kind of growing it fully grassroots, because for what it's worth, I am fully aware that the first few minutes that some people publish videos, they get more than 4.6 thousand views, like in the first couple minutes it gets posted, and can probably get more than, 138 subs in that same time too when they post a new video. But one thing I do want to reiterate, which I believe I've kind of mentioned at multiple times, is this podcast is fully driven by you all. So you, the listeners, my fellow assassins, you are the ones that drive the success and the reach of this podcast. Because one thing that I do not do at all is publicize this in any way. If you go to any of my personal social media feeds, you will see absolutely zero mention of this podcast anywhere. The only way that you can kind of see that I'm affiliated with it at all, if you know where to look, is if you go to my website and then you happen to see that I am affiliated with Dark Assassins Inc., and then you kind of can meander your way there and maybe see a tangential relationship possibly. But I don't do any personal publication or publicizing of the podcast. Now, while I was emphasizing YouTube right there, I do also want to give a huge shout out to all the loyal podcast listeners as well. Those of you who have been listening since the beginning on the various podcast platforms, whether that's Apple, Spotify, iHeartRadio, or wherever you get your podcasts. And I guess I do have to give a quick caveat. The only 2 instances where I have mentioned in public to someone else, well, I guess family, excluding family because they obviously know, but aside from them, the only times I have divulged, I guess, the fact that I have a podcast is, of course, Das Dude 1, because he's been on the podcast before. I kind of had to tell him I had a podcast in order to get him on, and then the other one, when I was recently moving, when I had some people come over to my house to remove some stuff that I didn't want to take with me, they kind of spotted some of the recording gear, and I kind of got questioned about it, so I gave them an answer. But aside from those 2 cases, I just don't publicize it. I don't talk about it. So props and thanks to you all for doing all of the hard work in the trenches of sharing this around to your friends, your family members, liking videos, subscribing to the podcast, all of that good stuff, leaving comments, everything. It definitely helps out the podcast grow, and is basically why I keep doing this. So here is to year 4, and thanks again for spreading the good word. And this episode specifically, I kind of wanted to have a little bit of fun this episode. Now, as I was actually recording the intro, the whole welcome my fellow assassins bit at the very beginning, I was thinking that, if I was actually a good podcaster, I probably would change something up year over year. Like, either you change the the intro, or you change the music slightly, or something to that effect. But obviously, as you are well aware from how this podcast episode started, I did not do that. But maybe the 5th year anniversary. I don't know. Probably not. But we'll see how things go. But anyway, so the couple things that I wanted to talk about in this episode, there is a interesting cybersecurity tip from an instance where yours truly almost got caught by a phishing scam. Didn't actually get caught, but it was very convincing. And then also I have a story of software development meets driving, and then I have some just generic Q&A from, generic questions that you might receive as a software developer, and basically what my responses to those questions are. So with that out of the way, let's get into our trivia question for the week. So this week's trivia question is: GitHub is a widely used platform for hosting remote repos for various open source projects. But what year was it founded? And bonus points if you can get the month and the day as well. So what year was GitHub founded? And that is your trivia question for the week. Yep, that is right. You heard that music. You know what time it is. It is time for another open source highlight. So this week I wanted to highlight a project called Curvature. And they're specifically, I'll have all the links down in the show notes, of course, but specifically the website Road Curvature. Now, if you're like me, you love a few things. One of them being writing tons and tons of code, tinkering around with a home lab, and driving on twisty, curvy, and technical back roads. Now, usually on this podcast, seeing that it is very software development and technology focused, I don't really get a chance to talk about that latter one. But for me, well, obviously we're talking about it now because this open source project that I recently discovered exists. But we usually, like I said, we usually address the former two, but not necessarily the latter. Now, before this week, typically what I would do if I wanted to find a fun road to drive on is I would pore over map data and just spend basically hours, searching maps for potential roads that might be curvy, twisty, and fun to drive on. And basically the only way that you can do that on, modern maps, whether that's Apple Maps, Google Maps, OpenStreetMap, whatever the case is, you have to zoom in really, really closely in order to actually see some of these good small back roads, because typically if you're zoomed far out, the only roads you're going to see are like your major highways and your interstates, which are typically pretty straight and boring, not to mention the fact that they're usually pretty congested, especially if you live anywhere near a city. Now, of course, if you live out in the middle of nowhere and you hop on the interstate, there's a good chance you're probably going to be the only one there. Obviously, there'll be other people, but it will be very, very, very light traffic compared to what you would see if you happen to be getting close to a city. Now, this was fine. I did find some pretty good roads this way. And the other method I would use to try to find good driving roads would be to just scour the internet searching for, best driving road in X place, or good driving roads in blank, or back roads in blah, 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 and I'd find, some various blog posts and internet forums discussing the topic. But that's hours and hours of research just to go have a fun drive. Because the thing with me is, like I mentioned, love driving, but there is a big ol' asterisk to that. I do not like driving when I am sitting in traffic, but if I am basically the only one on the road and it's a nice back road with lots of twists and turns, I'm having the time of my life and would love to spend hours doing it. So like I said, I recently, literally this week, discovered this site called roadcurvature.com, which essentially is a web front end for the project Curvature over on GitHub. Now, basically, how this app works, I guess, since I'll just talk about the website, because the back end is kind of where all the calculations go, but the website is where anyone can just kind of go and look at this stuff. So how it works is it basically does some math calculations, which we'll get into in a little bit, to highlight the twisty roads and basically hide all of the other roads. So if you go to the website and you click on the map, what you'll find is you'll find a bunch of different like highlighted squiggles all over the globe, and those are the various roads that are generally more twisty, curvy, and typically more fun to drive. Now, each road is colored and shaded in a different way, kind of determining on kind of how they rate on this curvature score, which we'll also get into in a little bit. So it basically really help you identify which roads are going to be probably pretty good to drive on, and which roads maybe are worth taking a road trip for in order to driving. Because yes, that is something us weirdos that like driving do, is we will literally take road trips to go find these fun back roads in order to drive them. It is something that we do. So basically how this project works is like I said, it removes basically all the non-curvy roads. So basically, unlike most maps where you see like the major highways and the interstates, those are basically completely removed. So you only get the twisty, curvy roads, which is very nice. And the way it gets all this data is through OpenStreetMap. So OpenStreetMap is basically like a crowdsourced Google Maps, if you will. So basically all of the data, all the street data, locations, images, everything is crowdsourced. And it's also free for anyone to access, which is kind of a big part. If you actually look into kind of the story behind how this application was developed, that was one of the reasons why the guy ended up going with OpenStreetMap, was because if you tried to get data from, like, say, Google Maps, it would basically cost you your soul, your arm, and a leg. So basically, in a nutshell, how this works is the back end, which is basically just written in Python, takes data points along the road provided by OpenStreetMap. So OpenStreetMap will basically have a bunch of different geographic coordinates for kind of where the road is, and you can kind of string those together to basically form the path of the road. So basically what the Python program does is it calculates the various radii, I guess, of the different curves on the road, and it can string together long stretches of roads that have a lot of curves in it. So if you've ever driven a road that has a lot of twists and turns, there's generally like maybe a couple miles stretch worth where they have a lot of twists and turns, then it might straighten out for a bit. So it's what this curvature is able to do is it's able to kind of pull out that one section and basically highlight it and be like, hey, this part is really curvy, and then just kind of like hide the rest of it, which is pretty cool because there are plenty of roads like that exist where parts of it are really twisty and curvy and very fun to drive, and then the other parts are just kind of your typical road. So it's, like I said, it's able to kind of string these together, drop out segments that don't meet those twisty, curvy criteria. And then, because the other thing too is, like, some of these roads, depending, like, for instance, U.S. highways, not to be confused with interstates, but U.S. highways typically can extend for hundreds, if not thousands of miles. And some parts might be a little more twisty and turny than others, and others are just kind of your typical straight shots. So you can obviously filter those out. It also has filters for unpaved roads too. So one thing, I guess the guy I think mentioned in one of the blog posts or whatever, is he noticed that there were a lot of roads that looked, potentially promising, but they ended up being just like dirt roads, which typically aren't necessarily the best if you want to kind of like carve through some back roads. Now, if you're into dirt roads, you can, you don't have to filter those out, but there is kind of like an option to filter those out. So one thing I talked about was each road is given a curvature score. So how the curvature score is defined is as follows. So a curvature score of less than 300 is, quote, might be a few fun corners on these, but these roads are predominantly straight and have long distances between each significant curve. So basically, if you see something less than 300, it's probably just going to be your typical generic road. From 300 to 1,000, these roads have several significant corners close together. They aren't likely touring destinations unless you're stuck with otherwise straight roads in the region. But if you're looking to spice up your commute with a few corners, these might be fun, more fun than the direct route. So yeah, kind of makes sense. Typically, if you're just trying to use your GPS to, say, commute to work, probably like 90 to 95% of the time, it's just going to take you the most direct route, which is probably mostly straight. Maybe you'll make some right and left-hand turns to change which road you're on, but overall, you're probably not doing a whole lot of curving and bending, winding around, which, depending on where you live, that literally might be the only option. There might not be multiple roads that you can drive on to get to where you're trying to go. Then we have a score of 1,000 to 3,000. This range has a lot of fun roads. They usually have a few dozen corners and generally feel more winding than straight. As we'll get to a little bit later here, my previous favorite road to drive on before the past few months or so did fall in this category, which it definitely fits this description. It definitely had a good number of corners to it, and it generally did feel a lot more windy than straight. But then again, comparison to some of the other roads, it kind of can't hold a candle, but we'll get to that in a little bit. 3,000 to 10,000. For much of the world, this range includes the destination roads that people may ride for hours in order to visit. These roads will usually have long sections of tight turns, often for miles on end. In the northeastern United States, the best roads are all in this range. So if you've ever lived in the eastern portion of the United States, I guess the Northeast in this case, but also really anywhere kind of in the Appalachian Mountain region, there are tons and tons of very windy, twisty back roads that generally rate kind of in this very high realm. And then we have any curvature score of over 10,000, and they say these are truly epic roads with miles upon miles of twists and turns. So the one thing that I really liked about this whole curvature score thing was the fact that it kind of gave that tangible number value to roads that I was used to driving on, to kind of give a little more, I guess, basically a confirmation bias, if you will, of yes, this road was better than this road, and here's why. Because before that, I could basically tell you, yes, this road was more fun to drive on than that one. Well, why was it more fun to drive? I don't know. I mean, I guess there was more turns, and I don't know. I guess it was more engaging. But here, you actually have a legitimate score associated to each of the different roads, so you can kind of have a direct apples to apples comparison. Now, granted, there is, I guess, a chance that you might drive a road that scores maybe 3,000, and then you drive another road that scores a 5,000, and then maybe you think the 5,000 wasn't as good, and that's totally valid and potentially very true. But typically, the roads that I've driven and compared on this chart have definitely kind of coincided with my overall thoughts on them. Granted, the deltas were a lot larger than, say, like maybe 2,000 points, but still kind of the point stands. And I also should mention, too, that the author does point out on the website that he basically had the exact same feeling about, it's nice to kind of have like this tangible number to kind of confirm kind of what he felt when he was, driving on some of these various roads. So one of the examples that I wanted to give for this has to be by far, hands down, full stop, the best road that I have ever driven, which is Tail of the Dragon. Now, if you've never driven it and you enjoy driving like I do, I cannot recommend I just can't recommend it enough because I would go back there in a heartbeat. Now, if you've never heard of the Tail of the Dragon before, it's an 11-mile stretch of road on US 129 in Tennessee. It goes from Tennessee to North Carolina, just into North Carolina, and it has 318 curves in those 11 miles. So if you do the math on that, that's just shy of about 30 curves per mile. Now, there's probably two main people that are listening to this, their reactions when they heard, 318 curves in 11 miles. The one side of the folks are probably like, that sounds exhausting. And then you have the other camp that's like, that sounds incredible, sign me up. I, of course, fall into the latter camp. But what makes it even better, at least in my opinion anyway, which of course I am very biased, is if you're coming from Tennessee, the actual kind of like trading post, general store, attraction area, like where the actual, if you go to the Tail of the Dragon website, there's that like picture of a metal dragon statue. The only way to get to there is if you're coming from Tennessee, you have to drive down the entire tail to get there. If you're coming from North Carolina, it's I guess the beginning. So if you're coming from Tennessee, you basically have to drive down the entire Tail of the Dragon to get there, and then if you're going back the way you came, you basically get to drive the road twice, which is what I did. And it was incredible, and quite honestly, it wasn't enough, because if I wasn't in the means of trying to get somewhere that wasn't... Basically what happened was the Tail of the Dragon was a pit stop for me. But if it wasn't a pit stop, I could have easily spent the entire day, if not more, just driving up and down that road, and I would have been having the time of my life. So if you do, go from Tennessee to, the general store area and then back up, then it's really a 22-mile drive with 636 curves, which, like I said, still wasn't enough for me, and I would have happily spent all day there. But the point is, the Tail of the Dragon, they divided it up, I guess, into two portions. The one portion of it scored a 27,385, and the other portion scored a 22,410. And if you'll remember from the curvature score, the highest number was 10,000 plus. So this is over double, and in one case, almost triple that. So yeah, it is fantastic. And I have told friends and family this before, that it was hands down the most fun that I have ever had in a car, and the score definitely shows that. Now, I would like to think that you could drive any car on the Tail of the Dragon and have a fun time, unless the car doesn't handle very well, in which case you're probably going to be scared for your life. But if you have a good car that handles pretty well, especially if you have a sports car, it is basically heaven. It is fantastic. The only, which I guess the other thing of it too is, depending on when you go, it can be very busy. Now, thankfully, when I went, I happened to go in their off season, which is basically the winter time, and I also went in the morning on a weekday, so I basically had the entire road to myself, which made it all the more fun. I have heard stories and kind of seen videos. If you go like during peak season, which I want to say is like March through sometime in like the fall time frame, so basically anytime spring, summer, fall, if you go there, especially on like a weekend or even a holiday weekend, it's going to be packed. So if you want to go and you don't want it to be super packed, probably a weekday would probably be your best bet. Or you could just do what I did and go in the wintertime, in the off season. The only downside to going in the off season is none of the stores at the bottom are open, so you can't like buy any merch or anything, which is kind of a bummer. But they do have an online store, so I guess that is a nice bonus. So if you can't actually go physically in the store and buy something, you could at least buy something after the fact. But my only regret, which had nothing to do with driving the Tail of the Dragon, the only regret that I had was on the way to the Tail of the Dragon, I passed by the Blue Ridge Parkway, which, if you're not familiar with the Blue Ridge Parkway, it's basically a road that drives like right through kind of like the Appalachian Mountains through like Virginia and North Carolina. And that was kind of the route that I was taking to get to the Tail of the Dragon. And Because of my severe lack of planning, I did not drive that road at all because I wasn't sure where it went. And if of course, if I actually would have looked at a map, I would have seen it was, basically going the exact route that I was going. So that was a massive bummer because if you go to, road curvature and you look at the Blue Ridge Parkway, it also scores very, very highly. So definitely a bummer that I didn't get to check that out. But I have a feeling that at some point I will end up going back through that way. So I will definitely make sure to add that to the checklist. And the other thing that I like about this too is now that I know that this amazing website exists, I will almost certainly be using it whenever I do any kind of road trip from now on, just to find out if there are any cool, like, good roads to drive on, like kind of on my way to wherever I'm going, so I can kind of get off the boring monotony of the straight highways and kind of have a little more fun. But anyway, the entire kind of reason why I went on this massive tangent. One was because I wanted to indulge myself and kind of relive the memories because they were so amazing. But two is I wanted to compare it. I mentioned and alluded to my previous favorite driving road, which scored a 2,511. So it was no wonder when I drove the Tail of the Dragon that I thought my previous favorite road was basically boring by comparison, because it was literally, according to the scores, orders of magnitude less than what the Tail of the Dragon was. Now, recently, I did discover my new favorite driving road, which is a little closer to home than Tail of the Dragon, because as much as I would love to go out and drive the Tail of the Dragon whenever I wanted to, I don't exactly have, multiple days to make a road trip out there and back. I don't exactly have that much time to take off of work. But so I did manage to find a road that was a little closer to where I am now. This was also before I discovered the road curvature app. And what I noticed was, so I thought the road was good. It obviously wasn't Tail of the Dragon good. I kind of joked to myself after I drove it for the first time that this is, I affectionately named the road, "We have Tail of the Dragon at home." Like, it was good, and it kind of had some parts that kind of resembled the Tail of the Dragon, but of course, it wasn't Tail of the Dragon and not as good, but it was still definitely a very good road and better than my previous favorite. And the score definitely shows that because it was also similar to the Tail of the Dragon. It was divided up into two main parts. The one part scored a 7,484, and the second part scored a 2,830, which kind of lines up to how I felt about it. That 7,484 section definitely was the part that I kind of attributed to "We have Tail of the Dragon at home," and then the other portion, it was all right. It was definitely had some twists and turns, and it kind of felt like what my previous favorite was. Like, it was kind of bendy and twisty, but it wasn't like super tight and technical, like, Tail of the Dragon or the other portion of the road. But it was still definitely a good road to drive on, and it was just really cool to see, looking at these roads on this app to kind of get those numbers and compare them. So the last couple points, I guess, that I want to kind of give here, it's just really cool to see kind of have some, I guess, tangible evidence, if you will, to back up your anecdotal evidence of how you felt about a road. But the other thing I also want to reference is, because I'm putting links to both the website and the GitHub in the show notes for you to take a look at, don't be concerned with the fact that the GitHub hasn't been updated in a few years, because how the website operates is the Python that basically calculates the data for these roads is updating monthly, so the website is always up to date. Because I mean, you get to the point with any kind of project where it's basically done, and there's really not much else to do with it, like, unless you want to add even more features onto it. That's kind of like what we call a feature complete project, and basically the only updates you make are like bug fixes, if there are any. But yeah, so don't be concerned that the actual code behind this hasn't been updated in a while. The map itself does update monthly or so. I guess depending on where you are, it might be a different time of the month. But it does update, monthly. So if you are, the other cool thing about this website too is whenever you kind of either zoom in on an area or kind of move around the map, that zoom value and the coordinates are programmed into the URL. So if you are, looking around the map in your area and you find a really cool road that you want to drive and you want to send it to some of your friends because you all want to go on a group drive together or something, you can literally, where you are is currently zoomed in, you can literally copy the URL, send it to them, and when they open the link, it will take them exactly where you were viewing, which is honestly very cool. So they don't have to, go hunting for it. You don't have to be like, oh yeah, so if you go over to, a few miles west of this town and then a few miles north and then zoom in like 5 scrolls, then you'll find it. Like, no, you can literally go exactly where you want, copy the URL and send it to them. And it's a done deal. So that was a very kind of, I guess, long segment. So I appreciate you for sticking with me if you're still here, letting me indulge in one of my other favorite things, that being driving and just cars in general. So if you are a car enthusiast or you're a motorcyclist and you enjoy driving back roads and you have never heard of road curvature or the GitHub project curvature before and you're interested in checking them out, I will have links for them down in the show notes. Again, cannot recommend them enough. And with that, let's move into this week's cybersecurity tip. So as I mentioned at the top of this episode, this week I was close to falling for a phishing attack. Now, I say close because I didn't actually fall for it, but initially when I got when I saw the first email, I was kind of fooled, at least at first glance, but because I do have a background in cybersecurity, there was a little bit of fishiness to it, so I did my due diligence, and I'm glad I did because it did end up turning out to be a scam. So basically what happened here was there is a PayPal scam going around where you'll get an email from DocuSign telling you about a suspicious transaction on your PayPal account. Now, when you get the email, or in my case, 4, which in and of itself was kind of a red flag, but when you get the email, it looks very legitimate. If you click on who it was from, it'll be, at least in my case, it was from a DocuSign, email address, so adding some legitimacy there. All of the fonts and kind of headers and imagery in the email was very much legitimate, so, good, I guess good on the scammers there. I did realize upon re-inspecting the emails that there were some glaring red flags in the email that I didn't pick up on first glance, mainly probably because I was because usually my first go-to is check who it was from, and more often than not, it's from some generic random email that has nothing to do with who it's claiming to be, and then I instantly know it's garbage. But because that actually came from DocuSign and everything else looked legitimate, I was scratching my head and kind of wondering, wait a second, is this legit? So of course, the first thing I did was, closed out the email and logged into my PayPal account just to kind of see if there was any kind of activity on there, which did have me a little suspicious because I do have two-factor authentication on my PayPal account, and seeing that I never got any kind of notification about a suspicious login attempt or got, a two-factor like text message or anything like that, I was a little suspicious that this email probably isn't legit. But as we've touched on before, there are ways to get around things like that, like especially if you're using two-factor with like SMS and whatnot. There is ways to like spoof phone numbers, so you can kind of basically hijack someone's phone number to get their two-factor code and kind of log in that way. But I logged into my PayPal account, and looked at all basically kind of looked through everything, didn't see any charges there, tried to look at the activity, didn't see anything. So that was a little suspicious, but I was like, okay, but if we're giving them the benefit of the doubt, theoretically, they're blocking the transaction because they think it's suspicious. So maybe that's why it's not showing up in my account. So I was like, okay. So after that, then my next inclination was to, okay, let me search the internet to see if this is actually a scam that's going on, because more often than not, if you get something kind of suspicious like this and you kind of like type in like some generics about it, like PayPal DocuSign scam or something like that in this case, if it's a scam, you're more often than not going to see pages and pages of results documenting the scam itself. And sure enough, once I searched that, it was plain as day that yes, this was indeed a scam. But then I touched on that there were some other red flags in the email that I missed on the first glance. The first of which was under the sender's name kind of in the email. They had an email listed, which I don't know how I missed this the first time reading it, but it was not a DocuSign email at all. So I don't know how I missed that. The other thing I missed too was the I guess it was the reply to email, and I think it was like a CC or something. They were the same email address, and they were not a DocuSign email address. So again, another red flag. So some pretty dead giveaways right there. The other thing is there's a couple ways that you can get around this and actually verify that this is a scam. Because one thing that they'll send you in the email is they'll send you kind of like an ID for the DocuSign thing, as well as a quote unquote link to it, which don't click on the link, by the way. But if you copy the ID that they send you, if you go directly to DocuSign's website, and you go to I think it's like what is it? It's like access documents or something like that. Basically, if you go there, you can enter the ID of the document, and it'll basically not work because, of course, it's not legitimate. So I guess the question comes down to how did this appear so legitimate? Well, it turns out that hackers are setting up DocuSign accounts, and by doing so, it allows them to use the DocuSign API to send emails that come from legit DocuSign emails. And because they're coming from legit DocuSign emails, they basically bypass all the spam filters that typical email systems have set up, because you can't necessarily do the red flag, that we always talk about, where, hey, this is, this is Apple and iCloud, and, there's an issue with your account, sign in, and the person sending you the email comes from a Gmail account. That's obviously not legitimate. But if you have, someone like in this case, a message from DocuSign coming from a legit DocuSign email address, it's really hard to, for any kind of generic spam filter to identify that as spam. Because the last thing that you want is to be filtering all of these messages as spam and not having people get their documents that they need to be signing in a timely manner. That obviously wouldn't be good. So basically how it works, like I said, they use the DocuSign API to send legit emails from DocuSign, and by also doing this, they have access to various templates in order to impersonate reputable companies. In this case that I experienced, it was PayPal. And basically the link that they send you in the email is obviously not a legitimate one. So definitely some red flags there. So if you do happen to be in the same boat as me and you get one of these emails, it is bogus. And if you want to verify that, you can copy the ID of the document. Again, don't click any of the links, but if you copy the ID and go to access documents directly on DocuSign's website and enter that ID in there, it will somehow give you some sort of error, whether that's this document does not exist or some other kind of error. It won't work, and that will give you your kind of telltale that yes, this is indeed not legit. I know, like the past few weeks, basically off and on, if it's not every week, it's like every other week. The cybersecurity tip has been, yeah, be mindful of phishing attacks. But as we kind of see over and over again, especially with the rise of, AI, general artificial intelligence, it's becoming easier and easier for threat actors to make very, very legitimate looking phishing attacks. And if you combine that with something like this DocuSign one, where they're literally coming from legit DocuSign email accounts, it's very, very difficult for your average non-cyber security minded individual to not fall for them, and to be able to detect that these are scams. Because like I said, I was initially fooled when I first saw this email and opened it. I was actually fooled into thinking that, wait a second, this actually might be legitimate, because it passed the initial smell test of all the fonts and lettering looked right. The email address was from a legit DocuSign email. But again, because literally because I have this cybersecurity background and know to check for these things, that is the only reason that I did not potentially fall victim to this phishing attack. And I know there are plenty of people out there that if they just do the generic checks of, okay, let me look at the email looks like a legit email, let me check the sender, yep, it's from the company that says it's sending it, therefore it must be a legit email, and they would get caught in that situation. So yeah, definitely be very, very mindful of anything that comes across via email. And again, this is another one of those instances where if you're ever suspicious about something in an email, even if it's just an email that looks very legitimate, don't click anything in the email. Go directly to the sources themselves and, basically get the truth that way, because that is the only way for certain to know that what you're, getting into is not a scam, and that the email is, basically verifying whether the email is legit or not. So I will have a link to a Malwarebytes blog post on this subject if you kind of want to look into it a little more. But yeah, that is your cybersecurity tip for the week. So moving right along, let's get into what nerdy stuff have I been up to this week. So I want to keep this relatively brief. But last week I touched on that I tried to get a Docker container working to build my Linux image that I had already developed scripts for. And this week I managed to succeed in that. So basically what it boiled down to was I didn't have all the packages that I needed to have installed, and then once I got those installed, basically everything worked. I did have to tweak a couple of things in the script, because when I was initially developing the script, I kind of already had the repositories cloned and everything. So I kind of overlooked a couple of edge cases surrounding that, so I had to put in some tweaks there. And one of the kind of, I guess, the biggest tweaks that I had to put in was the whole depth of cloning thing. So if you're not aware with how Git works, Git allows you to clone repositories, obviously, to kind of get a full copy of the source code. But in cases like, say, the Linux kernel, trying to clone the entire thing takes a very, 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 very long time. So Git obviously acknowledged this fact, and they have this thing called a depth parameter that you can pass to clone. And basically what that does, it only clones only down to a certain depth. From my understanding, I think it only clones to like the most recent change of the file. So if, say, the oldest file was changed, I don't know, say 50 commits ago, it'll basically clone back 50 commits and only give you like 50 commits worth of the history, rather than having to clone everything. Now, this is great if you only care about having the most recent copy of the source code and building upon it. But if you're kind of looking for my case, where you want to be able to build older versions of the different sources, like, say, the Linux kernel, maybe you don't want to build based off master, you want to build off an older version of the kernel, like maybe 6.3 13 or something. You can't do that if you do a depth of 1 thing. So I did have to kind of modify how that works. And just as an FYI, if you do kind of clone all of these and don't use the depth of 1 thing, it takes a significantly long time. But the other thing I noticed too when I was working on this was the glibc build. That worked pretty well. That worked good. And then I got moving on to the GCC component, which basically allows you to compile C programs like inside the operating system itself, which at least in the environment that I was using, which was on my R620, it basically over doubled the time it took to generate the ISO just by adding GCC. So yeah. But yeah, it ended up mainly just being a dependency thing. So once I got all the dependencies sorted out, it was pretty much smooth sailing at that point. But yeah, it was so cool to be able to, run this Docker file, which I ended up wrapping it in a script to essentially build the Docker file, extract the ISO from it, and then remove and clean up everything. Because if you are doing the GCC build and you only do a clone depth of 1 on everything, if you run the script to kind of clean up everything, you free up anywhere between like 20 to 25 gigabytes of space. So yeah, a lot. And that's not even cloning the full depth. So if you did that, it would be even more for sure. But yeah, so it was just so cool to kind of, run a script to build an ISO, give it back to me, and then basically upload it to my NAS, boot it into my Proxmox instance, and have the working Linux image there, and being able to, play around with stuff, especially the GCC build, getting to be able to run code in there. It was fantastic. So again, I have to give a major shout out to my R620 for being an absolute workhorse, compiling the Linux kernel, GCC, and glibc. I don't know how many times, but definitely a lot. I definitely needed to get myself one of Jeff Geerling's It's Been 0 Days Since I Recompiled the Linux Kernel, because that was basically all I was doing, trying to get this thing sorted. So yeah, that was the nerdy stuff. So to wrap up this episode, I wanted to get into some of the questions that commonly get asked to software developers and software engineers and kind of give my answers to them. So the first one, and probably one of the most common ones that you'll get, is what do you do as a software developer? And my smart aleck answer is I tell computers what to do. A more serious answer is basically that I write programs that either I want to make my life easier or provide a good learning experience to me, or in the case of my career, programs that help my company make money. That's basically how it works. But a lot of that, though, is, writing a lot of code, yes. But kind of like I mentioned, when it comes to software development, one of the biggest parts of being a software developer is your ability to problem solve. So whether that's debugging or kind of just coming up with solutions in general, those play probably as big of a part as writing code, if in some cases more a part than writing the code. The next question is a very good one, which is how do programming languages work? Now, this is a very good question for a couple of reasons. First, it shows the person, one, has a genuine curiosity of how things work. But two, it's a good question because obviously computers can't understand words. Now, with the whole general artificial intelligence and stuff, you can give it more or less plain English and it'll, understand what you're talking about. But if you're trying to run software on, actual silicon, it doesn't really know what you're saying. Like, it doesn't understand what a for loop is, right? It understands ones and zeros. It understands its assembly language. So it's worth reiterating that programming languages are just abstractions to make writing code to tell computers what to do easier. So for instance, a language like Python is a lot further removed from the ones and zeros than, say, assembly is, because assembly is basically more or less a one-to-one correlation with the ones and zeros, because depending on your computer architecture, you can map the opcode you want to do, whether that's add, move, load, store, whatever your opcode is, with like the various registers, and you can kind of easily set that value and easily translate it into the ones and zeros that make up what the CPU can actually understand. But when it actually comes down to how programming languages get converted to the ones and zeros, this is where things get a little interesting. So, of course, first you have your compiled languages. So these are your C, C++, Rust, Go, Swift. All of these are examples of compiled languages, which basically means you have to run your source code files through a compiler, which the compiler has a couple different steps, from things like parsing, lexing, and optimizing. We're not going to get super in-depth to what each one of those steps are. But suffice it to say, basically what the compiler does is it takes in your source code files and basically translates it into code that your platform, or if you're using a cross compiler, that platform can understand. So for instance, if you're running an x86 machine, your compiler will basically translate your source files into the ones and zeros that your CPU, the x86 architecture, can understand. Whereas, say you were building a Game Boy Advanced game, you're using a cross compiler. Basically, what that compiler would do was it would spit out code that the Game Boy's CPU would be able to understand, rather than the CPU on your system could understand. So these types of programs are generally significantly faster in terms of execution time, because there's basically no middleman. The code is literally just running directly on the CPU. There's no kind of need for any kind of interpreter or anything, and basically allows the CPU to go very fast when executing these programs. The next, probably most common one, is your interpreted languages. So these are mostly scripting languages, but not exclusively. So things like Python, Ruby, Perl, etc. And basically what an interpreted language means is there is an intermediary between your code and the actual CPU itself. So unlike a compiled language that before you can even run your code, you have to run it through a compiler to generate an executable, what an interpreter does is it basically, as you are running so basically you run your program, and as you're running the program, the interpreter is basically going line by line and on the fly translating what you wrote into something that the CPU can actually understand. So as you might be able to see here, there's a lot of overhead in that. There's a lot kind of that has to go on in order for the interpreter to ingest the line of code, or maybe the function, or however it's working under the hood, and then translate that into something that the CPU can understand, have the CPU execute it, then go back and translate the next part, and kind of, rinse and repeat. So these languages are very much not nearly as fast. They are slower than compiled languages, but they do have the benefit that you don't have to wait for your code to compile. So depending on how big your project is, like if you have a very large, say, C code base or C++ code base, like maybe the Linux kernel, you don't have to wait for the entire thing to compile in order to run and test it. Which is kind of a nice advantage, but also at the same time, you kind of have the other trade-off of your actual execution is significantly slower in comparison to a compiled language. Now, one thing that's also worth noting is, depending on the interpreted language, you might run into instances where the program works, and then you might get into a certain branch that you didn't get into before, and your program crashes, where there's a chance that a compiled language might have been able to catch that instance. But because an interpreted language is just kind of going on the fly, it's not necessarily going to catch some of those. Now, what I will say is this doesn't exclude things like syntax errors. Obviously, if you have a syntax error, the interpreter is going to be able to catch that. But the kind of the example that I like to give in how to understand the difference between a compiled language and an interpreted language is, think of this as speaking a foreign language with someone. So if both you and the person you're talking with are both speaking the same language, say you're both speaking English, you can understand each other very easily and things progress very quickly and you get going. But say you're talking with someone that speaks Spanish and you don't speak Spanish, so you have to have a translator to translate your English into Spanish for them. It's going to be significantly slower because you have to say what you want to say, and then the translator basically has to ingest that and then translate into Spanish what you just said to the person that speaks Spanish, and then it kind of goes in the reverse where they speak in Spanish, the interpreter kind of has to understand it, translates that back into English to you. So a lot more overhead, significantly slower when it comes to communication, and that's kind of the big difference between a compiled language and an interpreted one. So then we kind of get to another class of programming languages, which I kind of dub the intermediate programming languages. And these kind of blend the compiled and interpreted languages into one. And these are like your Javas and your C sharps. So they kind of mix the two because they don't compile to like machine code. So like they're not going to compile to an executable that can say run directly on your system. But what they do, like in the case of Java, for instance, is the Java compiler will basically compile your Java code into what's called Java bytecode. And the reason why the Java bytecode is important is because that's what runs inside the Java virtual machine, which is basically the runtime environment that allows Java to run a singular Java application to run on any platform, regardless of if it's macOS, Windows, Linux, whatever. So that kind of goes back to the old saying of that Java likes to say, which is write once, run anywhere, or as cybersecurity people say, write once, exploit everywhere. But the main thing to remember here is because the Java virtual machine kind of gives that environment, the Java bytecode can basically just be compiled once and then run anywhere. But it's better than an interpreted language because it's compiled down to the Java bytecode. It's very easy for the Java virtual machine to easily and efficiently translate that into something that the CPU can understand. So it's going to be significantly faster than an interpreted language, but it's not going to be as fast as, say, a compiled language. And then we get into the fourth one, which is kind of an oddball of sorts, which is the transpiled programming languages. And yes, that is a real word, transpiled. So basically, I kind of just threw this in for fun. Basically, what this is, typically you'll see these when someone is developing their own programming language because it's a lot easier. I guess maybe this is my own bias, but rather than writing your own compiler or your own interpreter to kind of produce the direct CPU instructions required for your program to run, it's a lot easier to basically take whatever code in whatever language you want to create and translate it into another high-level language and then have that language's either interpreter or compiler do the heavy lifting. So typically what I think a lot of people do is they'll write kind of their own kind of generic language, which then they'll basically translate into Python and then just kind of run it through the Python interpreter, and that'll work. I had an experience mainly just as a experimentation to try to see how this actually works. Is I made a very basic programming language, which it's basically just C++, but I did end up getting functionality for a custom print statement type thing. But aside from that was basically it. I guess the other thing I did too was you didn't have to specify a main function. But having multiple source files didn't really work at all. And if you had multiple source files and no main function, it would kind of freak out and it wouldn't work. So definitely not production ready at all. And it was mainly just kind of a learning experience. But basically how I ended up doing it was I took kind of laid out how I wanted the language to function, which basically was just C++ with some not as many namespace abstractions, I guess, and basically convert that into C++ and then run it through like either Clang or G++ or something like that to get your, your compiled version. And it definitely worked. I was able to write programs in my programming language and use the compiler that I created, or I guess transpiler that I created, and it worked. And that is something that you can do. But just keep in mind, a transpiled language just basically takes a programming language and converts it into another programming language, and then that programming language will handle how you end up either interpreting or compiling or whatever. So that was a very long answer to that question. But let's try to speed through some more of these here. So the third question here is definitely a very common one, and it's kind of field agnostic. Is how did you get into the field, right? So how did you get into software development? If you've listened to the podcast for a while, you kind of already know this answer. But the short version of the story is back in high school, a friend showed me how to make pop-up message boxes on Windows, which I thought was the coolest thing in the world. And that basically kind of sent me down a rabbit hole of trying to figure out what else I can do. And then eventually I took some intro to programming classes in high school, and then basically the rest is history. Next question. What kind of projects do you work on? So this is a classic technology answer where it depends. And it really depends on what you're talking about. If you're talking about personally or professionally? Now, personally, I have, as I've stated before on the podcast, I have too many personal projects to count. I constantly lose track of them. But some of my favorites are my video game that I've been working on for the past, really off and on, for the past 3-4 years. I don't remember. It's been a while. I think I started in December of 2021, I think. So, yeah, about 4. So we're going on to the 4th year. So it's been 3 full years, I guess. But again, that has been very off and on. I really haven't touched that in a while, and I really need to get back into it. But yeah, that's one. The other one is my Server Connect script, which is basically a way to manage SSH connections. I've written a handful of just general C libraries, but typically the programs that I write, unless they're like specifically for like experimentation or a learning purpose, it generally falls into the camp of this would be nice to have, or it'd be nice if this existed, or basically something to automate something is generally what I kind of shoot for when I work on personal projects. And then in terms of professionally, basically whatever my employer, whatever team I'm assigned to at the time is what I work on. Currently, right now, I'm basically just working on a security monitoring tool, and that's all I'll say on it. Favorite part of being a developer? Probably the problem solving and creating cool projects or applications that make people's lives easier is kind of what drives me. Writing code, like I said, is very fun. I enjoy doing it. But writing an actual project and kind of seeing it, get across the finish line and making, whether it's an automation to make your life easier or whatever the case is, those are definitely very rewarding. So take for instance the Server Connect program that I touched on. The main inspiration for that was I didn't want to have to manage an SSH config file, in part because I had created one at one point and then forgot it existed and forgot how you create one. So I wanted an easy way to manage SSH connections. So that was kind of the genesis of it. Of course, now I know SSH config files exist and I could easily make one. But the nice thing about this tool is you don't have to actually worry about managing any files. It's basically all done through the command line tool. You can add connections, remove connections, update connections. There's been a bunch of functionality that I've added over the years. Initially, it was literally just a wrapper for SSH that would store your connections in basically a text file, and then kind of read them out, parse through which connection you wanted to connect to, and it would just SSH into it. Then, of course, like most projects that I work on, I make changes when I find, something that I want to do. The biggest one I made after SSH from my recollection was it was very annoying to have to, if I wanted to copy files to one of my servers, to actually have to type in the username and the IP address. It was very annoying. So I was like, what if I added SCP support into my program? So I added SCP support. Wouldn't it be cool if I could add Wake on LAN support? So implemented Wake on LAN support, and that's basically kind of how the project grows and continues to grow. Is basically I think, what's something I do specifically in my home lab that would be very nice if I could just use the name of a connection to make it do the thing. And that's kind of how I come up with new ideas for it. And I will say, when I first created the script, my home lab didn't necessarily really exist, but definitely now that my home lab is very has a lot of different servers in it, a lot of different virtual machines, having this program is vital. I think I've said it before, but out of all the personal projects that I've worked on, this is the only one that, so a lot of the projects that I make, I like to think that they would make either my life or someone else's life easier. But the Server Connect program is literally the only one that I can honestly say I use on a daily basis and actually makes my life easier. Which is why, even though it isn't, my most starred or forked repository on GitHub, it's still always pinned there, because to me, that is like one of my favorite projects that I've worked on, just because how much I use it and how much I rely on it on a daily basis. So let's get into another question here. Can you explain what coding is in simple terms? So I like to think of coding as like writing a recipe, an instruction manual, or giving someone directions, because literally all recipes are algorithms. Of course, algorithms is kind of a big, scary word, but in computer science and writing code, algorithms is one of the core fundamentals of any kind of program. Just like in baking or cooking, recipes are kind of the core of any kind of good cooking experience, I guess, or any dish. Same thing with instruction manuals, right? Instruction manuals, just like code, tell you how to assemble things or how to use the final product. So like instruction manuals will either tell you how to put something together or how to use it. Similarly, that's basically what code does to the CPU. It's just a bunch of instructions telling it what to do. And then, of course, giving someone directions, it's kind of similar to coding. You're basically telling the CPU what to go, where to go. And if you get down into the real weeds of it, if it, like when you get down to it, basically all you're doing is telling the CPU to load numbers into memory, do some calculations on them, and store them back into memory. So you're basically telling it what to grab, where it should go, and kind of directing it that way. So that's probably the easiest way I can explain it in simple terms. Is it's basically like writing a recipe, an instruction manual, or giving someone directions. What tools or software do you use daily? I guess this is also kind of one of those where it depends. It really depends, on what project I'm working on. Of course, text editors is the big one. VS Codium is kind of my go-to. If I'm on a Mac and I'm doing something a little more intensive, like if I'm making either a Swift app or my video game, for instance, I use Xcode. Of course, compilers and interpreters like GCC, Clang, Python, Java, that kind of a thing. Infrastructure and development environments are big ones. So it's awesome to have a very powerful machine to compile code on and test on. But of course, if you want to support multiple operating systems and multiple platforms, it is very nice to have a nice infrastructure at your disposal of various development environments that you can build and test code in across various operating systems and architectures as well, which is nice. Other things, of course, Git for version control, virtual machines, kind of like I touched on with infrastructure, Docker containers as well for things. I literally earlier on in this episode, I talked about using a Docker container to compile the Linux ISO I was making, and then Valgrind and just debugger tools in general are also definitely big helps. How long does it usually take to develop an app or software? Uh, Say it again with me, ladies and gentlemen. It depends. And this is the reason why this is such a hard question to answer is it really, really depends on what kind of application or software you're creating. Because if we're talking about an app to just do one thing, like store a Snapchat conversation, or a video game, the scope of those are very, very different. And for some basic apps and like command line tools and stuff, I could potentially knock it out in a weekend or maybe an afternoon. But if it's something, a lot larger and more complex, yeah, it's going to take, a few days or weeks or months or years in order to get across the finish line. But when you're talking about like a professional environment, it also depends on how many people are working on it, how many hours each person's tied to it. Are they working on other things? There's a lot of kind of variables that go into how long does it take to create an app or software. Next one, what is the difference between a website and an app? I guess this also depends on who you ask. Depending on who you ask, there literally is no difference. I tend to disagree with that sentiment. But there are a lot of various JavaScript frameworks out there that basically allow you to write web applications, which basically are just websites that themselves are basically applications. And then through the various JavaScript frameworks, you can basically convert them into either desktop or mobile apps as well. So basically, it's literally just a website that you can also create into an app. So from that perspective, they're the same. But obviously, performance is not going to be nearly as good as an actual dedicated application. For instance, if you create a JavaScript app, say with something like React Native, to create an iOS and Android app, that app isn't going to be nearly as optimized in performance as if you actually wrote it in either Java, Coltan, or in the case of iOS, Swift. If you write it in the native platform language, it's obviously going to be a much better user experience and a lot more optimized. But the main difference, in my opinion, is websites are something that you access on the internet via a web browser. So the web browser kind of being the key distinction there. Whereas applications are something that you run directly on your machine. So whereas websites, the actual code for the website is hosted on a server somewhere, an application, the code to run the application is on your local machine, whether that's your desktop, laptop, phone, whatever. The majority of code is on your device. Now, granted, basically every application these days has some sort of internet connectivity, whether that's to download updates or reach out to download content or whatever the case is. But the fact of the matter is the code to actually do that stuff is on and running on your machine. Now, yeah, it's probably going to make some requests out to the internet to other servers where other things are hosted, but the core part of the code is actually on your machine. So in my opinion, that's kind of the big difference between a website and an application. How do you test your code to make sure it works? Test in production, of course. Just push all of that code to prod, and your customers will let you know if there's any issues. On a more serious note, though, well, I mean, in fairness, that is a definite way that you could test your code. You probably won't have very happy customers if they're using your application and just it doesn't work. But they will definitely be sure to let you know. But yeah, jokes aside, there are a few ways to test code, but it basically all boils down to automation. Because if you can't, especially if you have a code base that is larger than, say, doing like one or two functions, ensuring that it always performs as you expect, even when you make changes elsewhere in the program, is very hard and very tedious and very time consuming to do if you don't have some sort of automated test suite out there, test suite included. Now, there's different frameworks that you can use depending on which programming language you're writing in, or you can roll your own automated test suite. But the fact of the matter is, you should have some way to ensure that all of your tests get run every single time before you push anything into a production environment to make sure that your code actually works. But it goes even further than that, because you also have to make sure that your test cases are actually good, because it's very easy to write very bogus, bad test cases. It's very easy to write a test case that, we'll take an easy one, tries to add two numbers together. Give it 1 and 2, and it should give you 3. Give it 1 and 4, and it should give you 5. Okay, it passed the test. Well, that's not a very good test, because what if you have a negative number? There's no edge case checking in that case, right? So having thorough test cases that, thoroughly test edge cases is very important when it comes to ensuring that you're adequately testing your code. And the other thing that's also important too is code coverage. So the idea of code coverage when it comes to test cases is this idea of making sure you go down all branches and paths in your code base. So typically, if you write a function, you're probably going to have an if statement in there, which is basically checking if something is true or not. Now, whenever you have an if statement, that's what's called basically a branched scenario, where you have like your if else or your if else if, and you basically have these different conditions where if this thing is true, do this, if that thing is true, do that, and so on. So having test cases to thoroughly test each one of those different chains is very important that you do, because a lot of times what people do is they'll just kind of give it a few test cases, see that it passes, and think it's good, when they might have gotten 3 of the 4 different cases, but they didn't get that 4th one that is kind of rare, but that 4th case isn't properly implemented, and when you hit that case, either the program crashes or it doesn't give you the output that you expected. So that is something that's important to kind of keep in mind. The other thing too is having some sort of CI/CD pipeline, continuous integration, continuous deployment, set up with your automated test suite included. So basically ensuring that the only way your code even gets to production is if it passed all the test cases. Because one thing you can do with CI/CD pipelines is if your code is chugging along and it fails a test case, you can just kill it right then and there, and basically stop it from going any further. Which is definitely a good way to prevent some very easily avoidable bugs in the process of development. So basically making sure you have very thorough test cases that test basically as much of your code base as you can, making sure you go down each one of the different paths and branches, and also automating it as much as possible. Let's see. We're basically close on time here. I did have a few other questions, which unfortunately we're not going to be able to get to. Let's see. This one's kind of long. These two are kind of short. We'll try to touch on them real quick. Do you work alone or as part of a team? I am a lone wolf. I work by myself. I'm just kidding. It really depends on the project that you're working on. Of course, for all my personal projects, I'm of course just a one-man show. But I have basically run the gambit in my professional career as far as what the team structure looks like. I've been in situations where I am actually the only person working on the code. I've been in situations where, yes, I'm a part of a team, but I'm the only person on the team working on the code that I'm working on. No one else is even working on that code base. And then I've also been on teams where we're all working on the same code base. So it really depends on the team and kind of what you're working on. The last one that I'll touch on is, what advice would you give to someone interested in learning to code? Again, I think I've kind of hit on this in previous episodes as well. But my recommendation is always to find something that you're passionate about. Find some kind of application or project that you want to make. Don't, just try to implement something because there's a tutorial on it. Find something that drives you. Find a project that you are inspired to make. Whether that's, a basic, application or whatever. But you also want to not make it too complex, right? Like if you set out with the idea of, I want to learn how to code, and my first thing I'm going to code is like a AAA game or some kind of video game, you're going to quickly quit, because those types of things, the scope of that is just way too large, especially when you're just trying to learn the basics. But some good recommendations that I have, do something simple. Maybe like you make a calculator app, or maybe you make a simple game like tic-tac-toe or rock, paper, scissors, because a calculator app is, depending on, I mean, you can kind of basically make it as fancy as you want. You could make it just a command line based one. You could make an actual GUI application or a graphical user interface one. And the good thing about, some of the games like tic-tac-toe or rock, paper, scissors, especially if you're making an AI component to it, like especially with tic-tac-toe to kind of make it somewhat smart, there is some like actual kind of algorithm and critical thinking that you do have to think about when actually implementing that, which is a good challenge. Plus at the end of the day, you kind of get a cool game out of it. Again, like I said, some of the first projects that I got into when I was first learning to code was like, basic physics calculations, like time dilation. I wrote my own quote unquote time machine that basically would just take basically just a wrapper for the time dilation calculation. I did one for projectile motion where I basically was like, you're a fighter pilot in World War II and you're trying to drop a bomb, how high up are you and how fast are you going? Things like that for projectile motion, very basic things like that I was just kind of interested in, that I could, write a basic program in order to do those calculations for. So yeah, anything that interests you, kind of start with that as kind of your focal point, and use that to build on your knowledge. And also, don't try to go for breadth, I guess. Like try to focus in like on a singular programming language first to understand the basics, because one thing that makes learning programming languages easy is when you understand the programming concepts. So if you already understand how data structures work, how algorithms work, what for loops are, what if statements are, how to do while loops, switch statements, all these kinds of things, once you understand how to do those, it makes transitioning between languages a lot easier. Because if you already know either what algorithm you want to do or what kind of general code structure you want, like for instance, okay, so in this particular case, I want to have a dictionary that I will then iterate over, and then kind of convert it into an array and then sort it and then, blah, 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 blah. If you already kind of understand that that's what you want to do, it's very easy, if you don't know what programming language you're using, to easily look up, okay, how do I create a dictionary in X programming language? Or how do I write a for each loop in Y programming language? Or how do you get the point, right? But if you've never programmed before, you don't know how to come up with that solution in the first place. So you basically don't know what to search for, is I guess what I'm trying to get at. So really understanding the core fundamentals of, kind of the general building blocks of what goes into programming is probably kind of the biggest key. And that's where some of these, coming up with cool personal project ideas to kind of, test yourself and kind of, just write code and kind of work through these kinds of problems is a fantastic way to get, some good experience. And the other thing that's cool too is if you do kind of, write something like tic-tac-toe or rock, paper, scissors or something that already exists and you create your own version of it, it makes testing it so easy because there are so many examples out there of how this thing works that you can basically just do a one-to-one comparison of, does my program do what the other ones do? It does? Cool, it works. Whereas if you're creating something from scratch that no one else has done before, it's a lot hard. Well, I won't say it's a lot harder, but it's harder to get definitive, is this actually what it's supposed to be doing? Whereas if, say, you're writing a calculator app, it's pretty easy to know if your calculator app actually works. So yeah, like I said, there were some other questions I had, but we have gone, I think, on long enough in this episode. So I think that's where I will leave it. But before we go, let's get back to our trivia question for the week. So this week's trivia question is: GitHub is a widely used platform for hosting remote repositories for various open source projects. But what year was it founded? If you said 2008, congratulations, you got this week's trivia question correct. And as I mentioned at the beginning, there were bonus points up for grabs if you got either the date and or the month. So the date and month was February 8th, 2008. So if you said February 8th, 2008, well, I don't know what to say. Big kudos to you for getting that correct. So that's going to do it for this episode. So if you enjoyed it, definitely be sure to leave it a rating and review and subscribe if you haven't done so already. Also be sure to share it around with friends and family members. And if you have any questions about this episode or have any comments, topics, or ideas for future episodes, if you're on YouTube, you can leave a comment down below, or you can shoot me an email at contact@darkassassinsinc.com. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.